Namaste and welcome back, dear students. And I hope you had a great vacation and you're all set to start the new year 2021. A new year on a new note. And the new year starts with a new chapter. And the new chapter is chapter 3, Earth, Sun and Moon. So we'll all open our books to page 189. Yes, we start the new chapter today. Page 189, we'll open our books. And in this chapter, what we'll be covering is basically the solar system. This is a topic which we've been doing from class 3 onwards, so should be quite easy. So we'll be covering the solar system, the sun, the earth, the moon, and we learn something new, which is eclipses, and also we learn about tides caused due to the gravitational pull of the moon. So in today's class we'll be covering up the solar system, the sun and the earth. So let's start first with the there's a small exercise in your book. It says identify the objects shown in the picture below that we normally see in the sky. As you can very clearly see, the first one is, yes, the moon. The second one is the sun. And the third one are twinkling stars that we see in the night sky. Yes, objects seen in the sky are called celestial objects. Any object which is there in the sky, which you see, which is there in space but not a part of the earth, is called a celestial object. The sun and other celestial objects that revolve around it form the solar system. So in this case, the sun itself is a celestial object, but that plus the other objects which are moving around the sun, they all together form the solar system. Let us learn more about the solar system, the sun, the earth and the moon. So first of all, the solar system, the sun and the 8 planets that revolve around the sun together form the solar system. We've been doing this from class 3, right? That there are 8 planets, the sun, and I'm sure you know all the 8 planets and you're very comfortable with that. Other than the planets, satellites of various planets, comets and asteroids are also part of the solar system. And your word web tells you what is a satellite. A satellite is a celestial object that moves around a planet. Like in our case, in the case of Earth, the moon goes around the Earth. It is the satellite of Earth. There will be other planets which have satellites moving around them. They are called the natural satellites because they are there naturally. And artificial satellites are those which man has sent. So that's a different issue completely. Here we are talking of the natural satellites. Like we know that there are other planets which have more than one satellites. We have one satellite which we have called the moon. Its name is Moon, but it is a satellite. Similarly, you have maybe a planet like Jupiter which has more than 70 satellites around them and they have specific names to them. Right? So, Moon is the name given to this natural satellite which the Earth has. And what are comets? Comets are large chunks which go around and their orbits are much bigger than the orbit of the planets. Like we know our planets take around 365 days. Like in case of Earth, we take 365 days to go around. The comets go around the sun in maybe 700, 800 years, one round. So they have bigger orbits and they are chunks of small material. They are not a proper planet. The small material which is a frozen material basically. Then there are asteroids. Asteroids are chunks of rocks which are just floating around in space. They don't have a specific orbit in which they move around the sun. They are floating chunks of rocks in the space. They are called the asteroids. So the sun is at the center of the solar system. There are 8 planets revolving around the sun. These planets are Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus and Neptune. They revolve around the sun in a fixed path called the orbit. That's the fixed path which they take around is called the orbit. And as you all know, Pluto was earlier considered to be a planet, but now it is considered to be a dwarf planet and we don't count it in the planets of the solar solar system. So there is a very easy way to remember the sequence of planets. You have M, V, E, M, J, S, U and N. These are the first alphabets of the planets, and you can remember the sequence as my very energetic mother just served us noodles. So this way you can remember the sequence of your planets. Yes. Okay, now you can see all your planets in relation to the sun. Mercury is the smallest planet and is also the closest planet to the sun. So you can see Mercury is the smallest and is the closest one to the sun. Venus is the hottest and the brightest planet, and we also can see it in the evening, and is also called the evening star sometimes. When the sun is just going down and the night has just started, you can see it in the sky, and it is also called the evening sky, evening star. Next, Earth, it is also called the blue planet. There's lots of water on it, and when seen from space, a lot of blue color is seen. That is why it is also called the blue planet. It is the only planet where life is known to exist. Mars is also called the red planet. This is Mars, and it is also called the red planet. It has lots of deposits of oxides which give it this red color, and therefore it's called the red planet. Jupiter is the largest planet of the solar system, and it has the maximum number of satellites also, right? Next is Saturn. Saturn, it is the second largest planet after Jupiter. It has rings around it, and Saturn is so light that if there was a tub of water big enough to hold it, it would float on it. So it's mostly made up of frozen gases. Uranus is the coldest planet of the solar system, and Neptune is the planet furthest from the sun. See, if you see, we talked about Mercury being the closest to the sun, but it is not the hottest, whereas Venus is the hottest planet. Similarly, as we go away, the planets become cooler and cooler. So we would say Neptune is the coldest planet, but Neptune is not the coldest planet. Uranus is the coldest planet. And the reason could be that due to the atmosphere, it loses the heat more easily. So Uranus, therefore, and or maybe Neptune's atmosphere retains a lot of heat in its thing. So that is why Neptune is warmer than Uranus. So going by that system, we say Uranus is the coldest planet, whereas Neptune is the one which is furthest away from the sun. Next, we come to the sun. The sun itself is a star. See, basically what you see in the sky are also stars. This we've explained again in class 3 and 4 to you also. They are basically all our stars. But since this star is so close to what we see, to us, we see it as a huge bright ball of fire. But the other stars you see at night are also huge balls of fires, and some of them would be much, much bigger than our sun. But they look like tiny dots to us because they're very, very, very far away from us. But basically, the sun is also a star, or I could say all the stars we see at night are all suns of their own individual solar systems. So the sun is a star that is situated at the center of our solar system. It is a huge ball of burning gases. Its size is about 109 times that of the Earth. It is almost 100 times bigger as the size of the Earth. Its mass is about 330, that is 3,300,000 times that of the Earth. So it is much, much, much heavier than the Earth. It is almost 99.86% of the total mass of the solar system. So if you see, it is so heavy that entire solar system ka almost 99% weight is concentrated in the sun. So remaining some percent is the rest of the mass. So you imagine now, Earth is so heavy. Uska weight plus all the other 8 planets together, all the asteroids, all of these together also form just 0.1 something percent of the, I would say 0.14%. 0.14% of the total weight of the solar system. Hydrogen and helium gases are the major constituents of the sun. These two gases make up the major constituent components of the sun. The sun has a thin outer layer called the corona and a central part called the core. So the outer corona is rather thin and the central core is the more huge portion of the sun. In the core of the sun, hydrogen gas continuously gets converted into helium. It's a change in structure of the gas, and in this change a very huge amount of heat and light energy is released during this process. So during the change from hydrogen to helium, a lot of energy is released in the form of heat and light, and energy released by the sun is called the solar energy. The temperature on the surface of the earth is about 6,000 degrees Celsius, where we say boiling water is just 100 degrees Celsius. This is 600 times hotter than boiling water. So 6,000 degrees Celsius. It is very, very, very hot at the surface of the sun. So you can imagine the interior or the core of the sun, how hot it would be. All living things on the earth ultimately depend on the solar energy for their existence. And we've also studied this before, that earth is at a very comfortable distance from the sun. If it was too much more closer than what it is, then it would become too hot for life to exist, and if it was more away from the sun, it would become too cold for life to exist. So we are at a very comfortable distance, just right for the possibility of life to exist and grow on our planet. Next is our planet Earth. The Earth is the third planet from the Sun. It is surrounded by an envelope of air known as the atmosphere. The atmosphere of the Earth protects us from the harmful radiations of the Sun. As you all must have heard before, that the UV rays, ultraviolet rays of the Sun, are reflected and absorbed by the atmosphere. Excessive heat of the Sun is also reflected back by the atmosphere. So the atmosphere protects us from excessive heat and harmful radiations of the sun. The interior part of the earth is divided into three main layers: the crust, the mantle and the core. As you can see in this diagram, if I cut a slice out of the earth, I can see like this, that this is the outer crust. The crust is very thin. The outer crust is very thin. As the name says, crust is always a very thin layer. And after that it is the mantle. After that the whole thing is the core, which is divided into outer core and inner core. Right. So crust is the outermost layer of the earth. Its thickness ranges from about 5 kilometers below the ocean floor to about 70 kilometers below the land. So basically, if our surface of the earth is not a flat, round, a smooth surface like this, so it will have mountains, it will have oceans, right? So at mountains it could be up to 70 kilometers also, but near oceans it would be around 5 kilometers below the ocean floor. The continents and the oceans are on this layer. It is made up of rocks and contains all the things essential for life. Next is the mantle. Mantle is the middle layer of the earth, lying between the crust and the core. The thickness of the mantle extends up to 2,890 kilometers. The outer region of the mantle consists of solid rocks. The inner regions of the mantle consist of molten rocks. See, basically what happens, it's no such hard and fast one line and yahan crust khatam ho gaya and here the mantle starts. It's nothing like that. It's a slower transition. So obviously here it is rock hard, then the rock starts slowly melting. By the time they come to the center, it is now molten rock. So the molten rock, if you remember, we done last in the previous chapters, is called the magma, and the magma comes out through volcanic eruptions and forms rocks outside, right? So that magma or the molten rocks is slightly on the lower side. In this side you will have more harder solidified rocks. So the inner regions of the mantle consist of molten rocks. During volcanic eruptions, the molten magma comes out from this layer to the surface of the earth. Last but not the least is the core. Core is the innermost layer of the earth. It is mainly composed of iron and nickel. These are the two main components of the core, iron and nickel. The outer core is in a molten liquid state. This is the outer core. It is in a molten liquid state. It extends to about 3,400 kilometers. So this is something like, this distance is 3,400 kilometers. The inner core is in a solid now. Now you will say, ma'am, the internal part is the most hottest, so it should be absolutely liquid. This, as we say, the outer crust is the coldest part, so it is solid hard, and as we come inside, the heat increases. So this is rock-like mantle, and then we have molten rocks, and then we have molten outer core. But how does the inner core become so solid? The reason is very simple. All these upper layers are putting pressure. So due to the high pressure, the liquid changes into a solid over here. So the inner core is in a solid state, whereas the outer core is in a liquid state. So the inner core is a solid sphere of mostly iron situated about 1220 kilometers from the outer core. From the outer core, this circle is about 1220 kilometers in diameter, and it is a rock hard solid substance, right? And with this, we conclude today's part of the chapter. That's all for today, and thank you very much, and bye from Abha ma'am.